Okay, very good. Here we have exercise 11 through 12. Write a function that models a given situation, determine the domain for a situation, graph the function using that domain, and identify the range. So do we have to do that necessarily in this order? No, we don't. But what would you do in this? How would you think about this?
12 is x. That's all I've got.
12 is x.
Because it's per hour.
12x equals 45.
12x equals 45.
I don't know. Oh man, I think it's like 12x. I don't know. I get confused when all this stuff happens.
Well,
The time is the x, 12 miles per hour from
12 miles per hour is the y, and the 9 is the x.
Yeah, because it's 12 is the speed.
12 is the speed, okay? But it says per hour. So when you translate this into mathematics, what is 12 really going to be?
X.
Per hour.
Yeah.
What is 12 going to be?
Time.
Distance.
No?
Time per hour of time.
Okay. Pardon, what did you say, Riley? Okay. Let's go ahead and look at this. I'm going to go ahead and do a little graph of this. And stop me if you have questions. But one thing we're going to look at is sort of learn how to look at these sorts of problems. And one thing that is very helpful is to understand that usually when you have relationships between time, and there's time involved here, right? 45 minutes, and another variable, in this case distance, usually time goes along the horizontal axis, okay, or the dependent axis. So we'll call this down here time, and we'll say equals minutes, right? And how many minutes did we go here? 45, right? So we'll put 45 right here. And then says, write the function. We don't have a function yet, but do we have a domain already? What's our domain for this? It says, 0.45, and it says what? Use set notation. So set notation is, we'll have t such that t is, what's the less t can be, right?
Is 0? Yeah.
45. So there's our domain. And do we have a function yet to model the situation? Not yet. Well, let's work on that. What next do we? By the way, 12 miles per hour. When we see something per, what this means is that this is a rate of change or a slope. Okay, that's what 12 is. Somehow. Okay. Now, what next would we do? Find the range? Okay, what would the range be? How would you find that?
12 miles an hour is not a distance, right?
Yeah, 12 miles per hour is not a distance. It is a rate of change or a slope.
It would be, so if you want distance, the max would be 9 miles.
9 miles? Okay. What I'm going to do is I'm just going to write down a range like this. And we'll call this D equals miles, and we'll call this 9 up here, right? And so we'll say D such that D is greater than or equal to 0, less than or equal to 9. And then
Wait, where'd you get 9 from?
Ben is going to tell, Ben will tell us. Go ahead, Ben, tell us.
You can go to 12 miles in 1 hour, so we only have 45 minutes, and that's 3/4.
Ah, I got you.
So 3/4 of 12 is 9.
And so 3/4 of an hour, right? So 3/4 of an hour times 12 is 9, okay? So what makes this problem tricky?
So,
Yeah.
12 miles per hour.
Okay, to me, what makes this tricky is you're given 12 miles per hour, but 45 minutes.
Yeah.
So your units aren't consistent, right? You have to think, like Ben did, to change that 45 minutes into 3/4 of an hour to make that situation work. Now, what could you do at this point? You have a decision to make. Could you instead change that 45 to 3/4 and instead have time equal hours? Could you do that instead? Okay, Ben's nodding his head. What else could you do?
you can do it the other way. Change.
And the other way would be to change that 12 miles per hour to change it into
12 miles per minute.
miles per minute, right? And since we already have the graph like that, you want to just change that to miles per minute and use that? Okay, let's do that. So, how do we change that to miles per minute? We got 12 miles per hour, right? How do we change that to miles per minute?
Multiply by 60, because there's 60 minutes an hour.
Multiply by 60? Oh, so if we put 60, which would be minutes, right, per hour, what's going to happen here?
Cancel.
No, we don't cancel. We have hours squared. What do we have to do with this thing here?
Yeah.
Divided by 60.
So let's go ahead and try to divide by 60 instead, see what happens. So now we put 60 minutes and we put hour up here. What happens now?
Now they cancel out.
Now they cancel out, so what do we have in miles per minute?
12 miles per 60 minutes.
Which is 0.2 miles per minute. Right? So now do we have something we can work with? Yeah. Let's just complete the graph here. We got our endpoints. So there's our graph. We have our domain and range. What else? Oh, remember the equation, right? So distance is equal to what? 0.2 times the time. And so that's going to be our equation. Right? And it would have been the same thing if we kept the units and made this 12 miles per hour. This thing would have been here 3/4, and this thing here, the domain would have been changed to 3/4 instead. Okay, so just different ways of looking at things. Is there anything else we missed out on this? That's pretty much it, right? Okay, I want you to look at number 12. Just kind of tinker with that for a little bit, see what you think, and then we'll work it out together, all right? Okay, what would you think on this one here? How did you look at this one? What was your strategy?
Well, it would descend 4 meters in 1 second.
So Marcus says 4 meters descending 4 meters every second, is that right?
Yeah.
So what would you call that in the language of algebra? -4 would be what? In the language of algebra, what would you call the number -4 that you gave me? That you gave us?
Slope.
That'd be a slope? Are you good with that? Are you good with the slope? -4? Are all your fingernails yellow? Oh, except one? Okay, cool. All right. Yeah, so we'll say that slope, we'll say m is equal to -4, and -4 is in meters per second. Okay, everybody good with that? Okay, what next? That's an important thing right there. What next? Domain? Okay. So our domain is going to be, it says inequality notation, right? So domain is what? 0. Our variable, what variable do you want to use? T. Time, okay. And how much time? 6 seconds, right? So that's 6 seconds. We have that. Okay, good. What next?
0. The range.
Oh, range, okay. Range is what we're going to need at some point. Do all these have to be done in the same order as? So range, what's our range going to be?
0. 0 less than or equal to
Meters. Less than or equal to,
90.
is it 90?
90. Does that look right? Yes, no, maybe? Yeah, let's take a look at the graph. So we have this graph over here, and we know we're talking about time equals seconds, right? And we know we have 6 seconds total. And what's the starting height?
0. Oh, 90.
90, right? So 90, and we know that the elevator's going down, so this thing's going to go down something like this. Now, if this is correct here, okay, if this is correct, what would that be? Well, it would be, we would go all the way down to 0, right? Boom. 0 height, right? But is that really what happens?
No.
Pardon me?
But it only go down.
No, it goes down 4
24.
meters.
Goes down 24. Okay, so Gabby is entering the conversation. All right, Gabby, how'd you get 24?
Well, wouldn't it be, because if it's going down 2 meters every half a second, and we're doing 6 seconds, then it'd be 24, it only went down 24 meters.
So did you use a table to figure that out, or how did you figure it out?
I don't know.
Okay. Well, what it is you have your elevation is going to be your slope, right? -4t plus 90. And if we want to find our elevation, what do we have to do with that? We have to plug in 6 for t. So you get -4 times 6 plus 90. And when you do that, you're going to get 24 plus 90, 66. Okay, so we're going to come down in those 6 seconds to 66. So what is the graph of that gonna look like? Gonna look like this. Okay, we have our equation. We have our domain. Do we need to fix our range here? Let's go fix that. So what is our minimum value here? 66?
First, yeah,
Pardon me?
first 6 seconds. For sure. It's on there,
So 6 seconds, 0 to 6, our domain, 66 to 90 is our range. All right? Okay, I think that covers it, right? We did all the graphing, we got the equation, we got the domain and range. We're ready to go on to number 13. Okay, number 13 is an explain the error situation. Not fully modeling, but somebody, in this case Cameron, she has been working and she figured out an equation, she figured out a domain and range. Is that function right? Is both the domain and range correct?
No, it's not correct.
Okay, Ben says not correct. What do you think, Addie? You think it's correct?
Show me.
Riley, what do you think? Connor? Bryce, what do you think? Peyton, what do you think? You gonna let Ben do all the heavy lifting by himself here?
Yeah, you want Ben?
Ben's doing the heavy lifting.
I'll let you jump in.
Yeah, explain it. Why do you think it's not?
Ben's getting tired. Okay, Ben, help us out.
Well, it's wrong because in the third word of the thing, it says error.
That boy Ben.
He says the third's wrong because the third word says error. And so, by the way the problem is defined, just by that, you'd assume there was an error. So is that all the analysis you did for that, Ben, or did you do
No,
other?
so far.
Oh, that's good. I like it though. That's really good. That's critical reading.
That boy Ben. Why do you explain yourself?
Well, that was really
So why do you
good.
explain yourself? I heard?
So, yeah, you got it. Yeah.
What else? So Ben did that, right? So what else? Right.
Wouldn't the less than and less than and less than and less than signs be less than and equal to?
Okay. Jaden says equal to is possibility, right? And that makes 100% sense, doesn't it? Because
Don't you it?
so anyway, we'll say, so we know that. So that's a good thing. We will take that under advisement because that's correct. Good job. What else? Anything with the numbers themselves
Is
that
the domain wrong or am I, or maybe I'm just getting.
is the domain wrong?
The domain should be 4 to 10.
Oh, domain should be 4 to 10.
Oh,
is
it'd
what
be
you're
Yeah.
0 to 6 hours, yeah.
Okay, 6 hours. Let's do this. So no, we'll say is correct no. And let's explain what would be a correct domain. First, we're going to take what Jaden said, and we're going to go like that, right? And make this T, but how many hours are we talking about, really? 6. Okay, that's going to be our domain. And what about the range?
That's right, just equal to.
And what is the range going to be?
0 is less than or equal to n less than or equal to 25.
So is that right now?
Oh, no, wait, no. Because it says 25 tickets every hour.
Oh, okay.
Oh, so it would start at 25. I don't know.
Well, no, it's The zero's correct, but it'd be 25 times 6. then.
Got you, should be,
So 150.
yep.
150, right?
I knew that. I was
Now,
testing you out.
one thing you gotta be careful about too, is this is inequality notation. And this, what I'm gonna do now is it possible to have, like, to sell 0.6 tickets or 1.4 tickets? No, it's not. So really, time can be recorded continuously, but this type of things you can count would be better set up in set notation, right? 0, 1, 2, to 150. Because you really can't get it perfectly right with inequality notation. You understand what I'm saying, right? Because these are discrete counting things. But okay, because 4 p.m. to 10 p.m. is how many hours?
6.
And is that all the explanation we need
Mhm.
to correct Cameron? Okay, so let's go on to 14. Multi-step, what are we given a graph here and a function, what will be the domain range and behavior of, and end behavior of the function? So what is going to be our domain of this guy here?
Infinity? I don't know.
Yeah, we're talking about inequality notation first. Do we have any restrictions to this domain?
No.
No.
No, we don't. So let's go ahead and write this out. That's x is less than infinity. There's your inequality notation. What's going to be your set notation? X.
X is what?
Element.
Oh, yeah.
All real numbers, right? And lastly, we have in interval notation, we have.
So I got kidnapped. Colorado City.
Nope, it was a Chevrolet Silverado.
Okay, so there's your domain, and your range, is the range going to be the same?
Yeah, because
Yeah.
Yeah, range, so
Except
we
for
can
Y.
just copy here, y, yep, y. So we have that. In set notation, we have y such that y is element of all real numbers. And we have finally this looking thing here, right? Okay, good. And what is our end behavior? Because it says find end behavior. So as x approaches infinity, what does f of x approach? Infinity. And then as x approaches negative infinity, f of x approaches negative infinity. And then it says B, how is the range of the function effective domain is restricted to negative 4, 4. And we write the range in inequality using set notation, using interval notation. So how do we do this? How do we
The domain.
that's our domain restricted. How do we write the range? The range is going to be, and we know we're going to be in, well, we're starting out with, they gave us interval notation.
So it'd be negative 75.
Negative 75. Well, here's negative 4, right? So negative 75 there. We're given an equation, so let's go ahead and put in 4, right? F of 4 is equal to 4 cubed, right? Which is 4 cubed is 4 times 4 times 4,
A lot.
64. So that's 64. So we know our range is going to be, plug in -4, we get -64. And also we have, in inequality notation, we have -64. Okay, that's going to be between y, right? And then set notation. Y such that y greater than or equal to -64, but less than or equal to 64. Okay, so we got, and then it says, the last one, it says, graph the function with restricted domain. So here we are at -4 and at 4, so we can just go right here. Okay, does that about cover it there? Okay.
It's a lot of math.
I'll represent real world situations here. John James Audubon Bridge, open in 2011, the height. Draw, it says draw the cable, so the time made me think of putting time here, but it isn't really time, right? Maybe X and Y. Letting the x-axis represent the bridge deck. So here's our bridge deck, somehow. So that's going to be X. And what's going to be our Y-axis? The tower, right? And what are we given here? The bridge deck to the top of the tower is 500 feet. And the length of the cable is,
Hey, what's the new again?
yeah, 08, 308.
Oh, that's right there.
Yeah, so it's just about there. So anyway, yeah, we are kind of out of time to really, we probably need at least 5 to 10 minutes to finish this guy off. So we're gonna have to call it good. Hold on to that paper. We may just finish it off on Monday.